Hello, I am Teacher Melai and welcome to this lecture video. So we are going to continue our discussion about normal curve. So this is the outline that we are following. So in our previous video, we discussed the characteristics of the normal curve. And so we have still the following to be discussed: the area under the normal curve, standard scores and the normal curve, and finding probability under the normal curve. But in this video, we will just focus on the area under the normal curve. So in the given characteristics in our previous video, we mentioned there that the area under the normal curve is equal to 1, so which means half of it is 0.5 and the other half is 0.5. So we have here the area above the mean is equal to positive 0.5 and the area below the mean is also positive 0.5. So we are, of course, emphasizing here that the area is positive 0.5 in the right and in the left of our mean, simply because, of course, we do not have a negative mean. So in the area under the normal curve, we actually made, we are using table. So we have here the table under the area under the normal curve. So we actually can download this from the internet and we can find several areas under the normal curve with different legend. But for this area, so this is starting from 0 or at the center to the given value of z. So if we are going to inspect this table, we have here columns and rows. So for our first row, this corresponds to the value of the decimal in the second place. So we have here 0.00, 0.01, or in the hundreds, 0.02, 0.03 until 0.09. For the first column, we have here the values of a z, or the standardized scores. So it is given into the first decimal place or in the tenths. So we have 0.0, 0.1, 0.2, 0.3, 0.5 until 3. So if you notice here, as we increase for the value of the decimal, like for example, for the first row, from 0.0 to 0.01, so the value also increases. So from 0.00 until 0.0359. And if we will go down until 3, if you also notice here, we have increasing value until we reach the last one, it is 0.4990. So it is almost a 0.05 and it is the half of the circle. So we have the value of 0.4990, and if we will still find for the value, for example, of z is equal to 4, z is equal to 5, all values is approaching to 0.05. So it can be 0.499999999, because of course, again, of the characteristic of our graph or of our normal curve, which is it is continuous and it is asymptotic with respect to the horizontal axis, that if we extend the value of x to the left or to the right, it will never touch the x-axis. But the area under it, of course, is approaching to 0.4999 or approximately equal to 0.5. Okay, so Our next objective, so we are here to introduce to you first the table, and then the next one is how to use this table. So to use this table, let us consider, for example, items. So let's locate the table and our page. So let us find for the values of z. So let's make this sticker. Z is equal to 0.05. Z is equal to 1.25. Z is equal to 0.77. And Z is equal to negative 1.25. So we have here the following values of Z. So how will we know what is the area of this Z if we will use this? Actually, if we are locating for the value of the area given the value of Z, we are finding for the area. If we will use this table, we are finding for the area assuming that this is the normal curve. So from 0 to the value, which is the Z here, it is 0.05. So this is the shaded region. Or in general, so it is from 0 to the given Z. So if it is positive, and if it is negative, it is from negative Z. So this is what the table is giving us. It is from 0 to Z. Okay, so let us solve for the, or compute for the value of the area by looking at the table. So we are going to use the table. Zero 0.05. So we are going to start here and end up with 0.05. So what is the value? It is 0.199. So the area is 0.0199. Now next, 1.25. So let's move here. 1.2 and then 5. So what is the intersection of the two? So going down, it is 0.3944. While for 0.77, so let's go back to 0.7 until 0.07 because it is 77. So the value is 0.2794. While if it is negative 1.25, so as mentioned in our introduction, we have Z, positive value for Z and negative value for Z, but the area is always, of course, positive. So, and from the characteristic again of our area under the characteristic of normal curve in general, it is symmetric in a sense that the values of the area on the right side is also the same of the values located at the left side of our normal curve from 0 to the given negative z. So we can actually use 1.25. So the value of positive 1.25 is the same with the value of z, which is equal to negative 1.25. So the area is the same. It is still 0.3944. So that is how to use this table for us to determine for the area. Okay, let's go back to our let us also consider this. So our next objective is for us to determine the area under the normal curve given the following conditions. So the first one, so what if we are determining for the area under the normal curve? So let's consider case 1. So we are provided with a positive z-score, or it is from 0 to positive z-score. So to illustrate that, so this is the shaded region. And this is the positive z. So if z, for example, is equal to 1, then what is the area of this shaded region? So first, of course, let us locate what is the value of the area. So since this is the table from 0 to z, so we will just go directly to the table and see the value of the area. So let's go back in our table. So what's the value of 1 point? So this is 1.0. So the value is 0.3413. So this means that this area is 0.3413. Next. So for case number 2, so what if we are also determining for the area from 0 to the given negative z-score? This is in this part, of course, it's a negative z. So we have positive z on the right side and negative z on the left side. So we are just like using the Cartesian plane, or rather the number line, wherein, of course, the center is the 0, where the mean is located. So this is the shaded part. So if our z is equal to -1, because of course it is a negative z, so what is the area? So we were able to see that the area under the normal curve from 0 to +1 is equal to 0.3413. So the same with this table, or rather this figure, it is also 0.3413, because of course by its property it is symmetrical. So we have 0.3413 area on the right side, so we also have 0.3413 on the left side. Okay, next. So for our case number 3, so let us use this. So what if you are also given, so this is for case 3, let's consider in between. In between two positive z scores. So let's say this is 1 and this is 2. Positive 1, positive 2. And then the shaded region is in between 1 and 2. So how will we determine for the area of this region? So we were able to know what is the area of 1. Z-score is equal to 1 and that is 0.3413. So how about the area of our Z is equal to 2? So we have to go back to our table also to find for the value of that. So let's move. So here we go. The value of 2 is 0.4772. So it is equal to 0.4772. So how will we know what is the area? So for sure, just like with our discussion in our first case, so we have the area here is 0.3430 because it is from 0 to 1. But our concern is from 1 to 2. But we also know, so let us use the figure here. So we also know that from 0 to 2, so this, let me just make this higher to show that this is the 1. So this whole shaded region is from 0 to 2, and this is equal to 0.4772. Now, if I will remove this part from 0 to 1, because the concern is only from 1 to 2, so what will I do? So, of course, looking at this table, we will actually remove this part to get the area from 1 to 2. And we know that this area is 0.3413. So to do that, let's just move this below. So it is 0.3413. So to do that, as you can see, we are going to deduct it. So it is 0.4772 less 0.3413, and that is 0.1359. So this is the area. It is 0.1359. Okay, let us also consider case number 4. So for case number 4, so in between two negative z scores. To illustrate that, so it is on this side. So just like what we did in our previous example, this is -1, -2. So again, as mentioned, the area of z-score, negative or positive, is the same. So the area for z is equal to -1 is also equal to 0.3413. And the area for z is equal to -2 is also equal to 0. If we go back, it is 0.4772. And just like again with our example in case 3, though it is located in the left side of our curve, we will deduct this. So it is a area of z is equal to -2 less the area of z is equal to -1. So it is 0. Also 1359. So this is also the answer. Okay, let us consider case number 5. So what if it is in between positive z and negative z? So we have -1, for example, and then +1. So the shaded region is this. So we can actually see in our figure that either we are deducting or this is the shaded region. So again, we know that this is 0.3413. And we also know that this is 0.3413. So we can see here that the shaded region is merged together. So we are going to add it. So it is 0.6826. So this is the area. 0.6826. So that is if it is located at it is in between a negative and a positive z. So the same is true, of course, if we have a -2 to +2. So the shaded region is, again, this the region. And if the area of this is 0.4772, let us just double check, 4772. And the area of the other half is also 0.4772 because it is from -2 to +2. So we will just add 0.4772 plus the 0.4772. So the area here, so let's say this is the area of A from 0 to -2, area of B from 0 to +2. So we will just add A plus B. So we have 4, 14, 15, 8, 9. So 0.9544. Or if we have a negative 1 to positive 2. So this is the shaded region. Of course, again, the area here is 0.3413, and the area from 0 to positive 2 is 0.4772. So we will just add again the area from 0 to negative 1 and 0 to positive 2. So it is 0.3413 plus 0.4772. So we have 0.8185. Okay, let's just see. So case 2, case 4, case 5. So now let us move to case number 6. So what are other possible cases aside from the given? So what if we have a positive 1? It is above positive 1. So first, case number 6, above positive z. Case number 7, below a positive z. So how will we illustrate that? So let's use 1 again. So here is the shaded region. Okay. So here, from 0 to 1, we know that this is 0.3413. And this is 0.3413. And from 0, half of our curve is 0.5. So what will we do to get the area above a positive z? So to get the area of positive z, so we know that half of the area of our curve is 0.5. So we will just simply deduct 0.5 less 0.3413. Let's add 0, 0, 0. So it is 7, 8, 5, 1, 0.1587. Now, on case number 7, so we can see here that it is not deducted. It will be added. So it is 0.3413 plus 0.5. So it is 0.8413. So this is the area for case number 7 below a positive z. Now let's move to the next one. So case number 8. So for case number 8, let us also consider above a negative z and below negative z. Or it can be at the right of a negative z or at the left of negative z, or it can also be written as greater than the area is above, so it is greater than negative z, and below it is less than the negative z. Okay, so let us again illustrate that. So let's use negative 1. So it is above, so which means we will shade this part. And if it is below, we will shade also, of course, the left side of negative 1. So we know that from 0 to negative 1 is 0.3413, and half of our area under normal curve is 0.5. So which means, again, to get for the area, we will add 0.3413 plus 0.5, which is equal to 0.8413. Now, on this side, so we also know that this unshaded part is 0.3413 from 0 to negative 1. So how will we know what is the area from negative 1 to its left? So we can see here that the 0.5 will be deducted again with 0.3413. So we were able to compute this already. 0.15887. So this is the answer. So we actually have here case 8 and case number 9. Okay, so this is all for this video. Thank you for watching.